So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the product rule for counting, which is also known as finding the number of total combinations, and is very similar and linked to listing outcomes and probabilities. Now this topic involves finding the total number of possible combinations when combining events. Now this may sound very similar to listing outcomes and sample space diagrams and links to probability. However, it has been relabeled and reintroduced as its own significant topic. So one way of listing all the possible combinations, or finding the total number of combinations, is by actually listing all the possible combinations out. Now this can be a very time consuming concept, but it can make it easier for you to understand, but also be able to answer future part questions that relate to probability or particular problems with the number of outcomes or issues with the questions. So let's have a look at this first question. So let's say that we want to list all the possible combinations of picking a starter, a main and a dessert from this detail. Now one thing that I'd probably suggest that you do is probably abbreviate all of these. So if I just write soup, bread, and just refer these to their first letters, just to make it easier rather than writing everything out. Now I know I'm going to have some duplicates of letters, but we're not going to bother. So here we've got starters, we've got main, and we've got dessert. And again, I'm just going to put a line through that. And again, all we're interested in is the total number of combinations. So I've got S, and then C, I, then S, C, C, then S, C, B. So that's all the possible combinations of picking soup and chicken. Then I'm going to have soup and fish, and then T, C, B, F, F, S, S. And then I'm going to have S, and then vegetarian, I, C, B, 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 S, S. So you can see that for all of these, I'm going to have 9 combinations. And then if I then swap, that's all the combinations of picking soup. Now, if I multiply that by 2, because I've then got another starter, I'm going to have a total combinations of 18 combinations. So if you're going to this restaurant and you're wanting something different every single day in terms of your 3 choices, then you would be able to go for 18 days. So that would be a typical question. Now, if you are only interested in finding the number of combinations, then there is a much easier way of doing this rather than listing them all out, and that is by multiplying the number of possible options in each section together. So for example, multiplying the number of starters, the number of mains, and the number of desserts. So if I go back to the previous question here and go for another pen, so here I've got 2 options, I've got 3 options, and I've got 3 options, and if I multiply all those numbers together, I get the answer of 18 combinations, which again is the same answer as I got here by listing the combination out, but I did it in seconds rather than writing them all out. So, however, you do need to be careful where there may be some exceptions in certain sections. So, for example, let's say we wanted to work out the total number. So, find the total number of vegetarian options. So for example, looking at the starter, how many vegetarian options have I got? Well, I've got 2. In the mains, how many have I got? 2. And in the desserts, I've got 3. So if I multiply all of those numbers together, 2 times 2 is 4, times 3 is 12. So there are 12 vegetarian combinations. And there we go. So I don't have to list them all out, although I could have done, but it would have been very time consuming. And the number of marks will no longer reflect you writing down the options unless it actually specifies it in the question. Now, before we get started on some example questions, there is a copy of where you can I'll include a link to the Corbett Maths website where you can find these collection of questions, which I think are really good in terms of generalizing what's included on this topic and gives you a wide range of what to expect if these questions come up in an exam. one says that Benjamin picks a 4-digit PIN number from his debit card. Each digit is a number of 0 to 9. And Benjamin can repeat digits. His PIN number starts with 94. How many possible codes are there? So the first two numbers are fixed. So looking at this option here, well, how many options are there? That there are 9 options. Well, actually, no, there's 10 options because I forgot 0. So there's 10 options. I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for this one here, I've also got another 10 options. So then the number of possible codes they're going to be. So well, I already know that it starts with 94. So then the number of combinations are going to be 10 times 10. So that's going to be 100. The next part then says that Megan creates a 4-digit code with her debit card. The first digit is 2. And the 4-digit code is odd. How many possible codes are there? So let's start by just picturing those 4-digit numbers. Well, we know that the first digit is a 2. I was going for there. And we know that the 4-digit code is odd. So in order for it to be odd, it needs to end in either a 1, 3, 5, 7, or 9. So in all, there are 5 options for the last number for it to be odd. So in the second one, we're not really bothered. So that's going to be 10 options. For the third number, that's also going to be 10 options. However, in the last one, we've only got 5. So it's going to be 10 times 10 times 5. So there are 500 possible combination codes for Megan. So question 2 then says, in a school there are 20 students in year 4 and 18 students year 5. The head teacher wants to interview 1 student from year 4 and 1 student from year 5. The head teacher says that there are 360 different ways to choose a year 4 student and a year 5 student. Is the teacher correct? Well, let's have a look. So it's going to be 20 times 18. And if we type that into our calculator, 20 times 18, that does give us 360. So yes, they are correct. Then moving on to question 3, it says that a coach is designing a football strip. He has a choice of 4 different pairs of socks, 3 different pairs of shorts, and 11 different shirts. How many different strips are possible? Well, it's going to be 4 times 3 times 11, and that's going to be 12 times 11, which is 132. And again, note that the question does not ask you to list the combinations. So although there is a fair amount of space, we're not actually need to do that. So question 4 says Ethan picks a 3-digit number. The first digit is greater than 4. The last digit is a multiple of 4. How many different 3-digit numbers could he pick? So again, let's draw our boxes, which I think definitely comes in handy when working with these questions. Now the first digit is greater than 2. So that means that it's either going to be 3, 4, 5, 6, 7, 8, or 9. So there are 7 combinations. Let's not put a box around it because I don't want to get confused. So let's just put a little circle around it. Then it says the last digit is a multiple of 4. So which numbers are a multiple of 4 that are single digit? Well, that's going to be 4 and 8. So there are 2 options there. And we're not exactly bothered about the third digit. So that's either going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so there are 10 different options there. Now again, you don't need to list them out, but all I then need to do is multiply these circled numbers together. So it's 7 times 10 times 2, which gives me 140. Question 5 then says that Erin wants to buy a rug and a mirror. In the furniture, there are 16 different rugs and some different types of mirror. There are 144 different ways to choose 1 rug and 1 mirror. How many different types of mirror are there? So we've got, this represents the rugs and this represents mirrors. and this represents the number of combos. Then filling this all in, we get 144. We know this is 16, and we know that we're multiplying. So to work out the number of combinations for mirrors, we just need to do 144 divided by 16. So 144 divided by 16 gives me an answer of 9. Then for question 6, it says there are 3 dials on a combination lock. Each dial can be set to 1, 2, 3, 4, 5, 6, 7, or 8. And it says work out the total number of different 3-digit numbers that can be used. So again, let's draw our boxes. So here, reading the question carefully, that there are 8 options for each number. So that's going to be 8. That's going to be a possible of 8 numbers. And that's also going to be a possible 8 numbers. So we're looking for 8 times 8 times 8. Which is 512. It then says work out the total number of different 3-digit numbers that can be used that have 3 different digits. So let's have a look at this one then. So if we're looking at this, so 3 different digits. Well, how many numbers can be used for the first one? Well, that's going to be 10. Then we can't use the number that we've used first, so there's going to be 9 numbers there. And for the third number, well, there are 2 numbers that we can't use. So 10 to choose from, 2 we can't use. So that's going to be 8. So that the answer then is going to be 10 times 9 times 8, which is 720. Then with question 7, it says that Jack picks a 5-digit even number. The first digit is a prime number, third digit is odd, and the fourth digit is 8. How many 5-digit numbers could he pick? So again, let's label up those 5 digits, and we know that it's even. So that means that if it's even, that it's got to end in either a 0, a 2, a 4, a 6, and an 8. Now it says the first digit is a prime number. So how many prime numbers are there between 0 and 9? Well, 2 is prime, 3 is prime, 5 is prime, 7 is prime. So there are 4 possible combinations. The third digit is odd, so that's going to be a 1, 3, 5, 7, and a 9. And the fourth digit is 8. So let's have a look at how many different combinations we could have. Well, for the first number, we've got a total of 4 options. In the fourth number, that can be any of the numbers, so that's going to be 10. In the third number, we can only have an option of 5. In the fourth number, that can only be 8, so that's a 1. And in our fifth option, that can only be possible of 5 numbers, so then I've just got to multiply all of those 5 numbers together. So 4 times 10 times 5 times 1 times 5 gives me an answer of 1000. Question 8 then says that Orla picks a 7-digit even number. The first digit is greater than 6, the second digit is half the first digit, and the third digit is less than 6. So let's have a look at what this 4-digit number can be. So reading the information that the first digit is greater than 6, so that's either going to be a 7, 8, or a 9. So there's 3 possible options for that one. The second digit is half of the first digit. So looking at this then, in terms of the 3 possible numbers that we could have, 8 is the only one that's an even number. So this must be a 4, because obviously then if it was a 7 or a 9, it's going to be a decimal number, which we can't have. It says that the third digit is less than 6. And so numbers that are less than 6 are 0, 1, 2, 3, 4, and 5. So there are 6 numbers to choose from. And it says that the number is an even number. So it's either going to end in a 0, a 2, 4, 6, or an 8. So there are 5 possible numbers there. So then multiplying this out, we get 3 times 1 times 6 times 5, which gives me an answer of 90. Moving on to question 9, it says that at Corbett's Cafe there are 7 starters, 16 main dishes, and 11 desserts. A meal voucher allows a customer to pick 1 starter, 1 main, and 1 dessert for £10. How many different choices are there for the meal? So this is going to be 7 times 16 times 11, and if I type that into my calculator, I get an answer of 1232. It then says 3 of the starters and 4 of the mains contain fish. how many different uses of their meal voucher but they do not like fish. So I need to take 3 minus 3 from the starters, so that's 4. I need to take 4 away from the main dishes, so that's 12, and there's no fish content in the dessert, so then that's going to be 4 times 12 times 11, and again if I type that all in or work it out, I get an answer of 528. For question 10, it says that Jackson makes a 4-digit number using all of these cards. How many numbers are greater than 6,000? So for a number to be greater than 6,000, in terms of the first number, it must start with a 7, 8, or 9. So there's 3 possible options. Then, as I've already used one of the numbers for the first number, that gives me a 3 left. Then I've got 2 left, and then I've got 1 number left depending on the option. So here then, if I then multiply these numbers together, I've got 3 times 3 times 2 times 1, which gives me an answer of 18. And with question 11, it says, in a gym, there are 7 exercise classes on Monday, 14 classes on Wednesday, and 12 exercise classes on a Friday. Max is going to attend either a class on a Monday and a Wednesday, or a class on Monday and a Friday, or a class on Monday, Wednesday, and Friday. Show that there are 1,358 ways to pick which exercise class he is going to attend. So looking at the first one, so option 1, this is going to be Monday and Wednesday, so that's going to be 7 times 14. Then for this second option, that's going to be 7 times 12. And then for the third option, that's going to be 7 times 14 times 12. So what we then need to do is add all of those numbers up. So I've got 7 times 14 plus 7 times 12 plus 7 times 14 times 12. And if I word those out individually, I've got 7 times 14, which is 98, plus 7 times 12, which is 84, and 7 times 12 times 14, which is 1176. Then if I add all of those numbers up, I get an answer of 1358. Then moving on to question 12, it says that James is creating a 6-digit code to lock his iPad. He only uses the digits 1, 2, 3, 4, 5, 6. He uses each digit once. How many possible codes are there? So again, let's just set up our 6 little boxes, or what resemble boxes. So here, if he picks, so in his first choice, he's only going to use each digit once. So there are 6 possible combinations he could have for his first one. Now he's already used 1 digit, so there's 5 possible numbers he could choose for his second. He's then used 2, so there's only 4. Then there's 3. Then there's 2, and then there is 1. So if I multiply all of those numbers together, let's have a look at the number of possible combinations. So 6 times 5 times 4 times 3 times 2 times 1 gives me an answer of 720. The next part says that Kelvin also creates a 6-digit code. He picks from the digits of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. His first 2 digits of his code is a multiple of 15. For the middle 2 digits, he repeats the same digit. And for the last 2 digits, Kelvin uses an even number between 25 and 45. So let's first of all start by sort of marking his 6 digits. So looking at the first 2, well, as it's a multiple of 15, then we're looking at 15. Now it has to be 2 digits, so we're looking at 15, 30, 45, 60, 75, and 90. So there are 6 different combinations that could be. It says for the middle 2 digits, he repeats the same digit. So it's either going to be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so 5, 5, etc. So for that, there are going to be 10 different combinations. And again, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. And then it says for the last 2 digits, Kelvin uses an even number between 25 and 45. So here we've got 26, 28, 30, 32, 34, 36, 38, 40, 42, and 44. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 combinations there. In which then, to work this out, all we then need to do is 6 times 10 times 10. So there are 600 possible combinations. So moving on to question 13, it says that in a class there are 12 girls and 10 boys. 4 of the girls and 2 of the boys are left-handed. A teacher picks 1 girl and 1 boy at random. What percentage of the possible pairings of the students are both students who are right-handed? So looking at this, if we look at the boys in terms of left and right-handed, and we've got the total. So we've got 12 girls and we've got 10 boys. Now of the girls, 4 of them are left-handed, so that means 8 are right-handed, and from the boys 2 are left-handed and therefore 8 are right-handed. So the question is asking what's the total percentage of possible pairings are the students going to have. Well, the total number of combos is going to be 10 times 12, which is 120. Now in terms of the right-handed, well, that's going to be 8 times 8, which is 64. So the percentage is going to be 64 over 120. Now, because it's asking for percentage, I multiply that by 100. And I get a percentage of 53.3%. And that's to 1 decimal place. Then moving on to question 14, it says Chris makes a 5-digit numbers using the cards below. How many different numbers are less than 70,000? So if we start up by sort of representing our 5-digit number. Now for it to be less than 70,000, this first number needs to start with either a 1, a 2, a 3, or a 5. So therefore then there are 4 possible options. Then if I've already selected one of those 4 numbers, then that means there are going to be 4 left to choose from. Then there's going to be 3 left, then there's going to be 2 left, and then there is only going to be 1 number left for me to choose from. So here I'm then going to do 4 times 4 times 3 times 2 times 1. So 4 times 4 times 3 times 2 times 1 gives me an answer of 96. So moving on to question 50, it says in year 10 there are 60 girls. 2 of the girls are going to be chosen at random to go on the trip. Lucky 2. Work out the number of different pairs that can be chosen from. Now for this, what we need to do is in terms of the first girl and girl, and we've got the second girl. So for the first one, there's a choice of 60, and then for the second girl, one's already been chosen, so there's 59 left. So then need to just multiply those 2 out. Now, the problem with doing this question, if you've not thought about it too quickly, and that gives us an answer 3,540, is the fact that the question's asking for different pairs. So what we've assumed, then what we've included, is basically the first girl and the second girl, but also the second girl and the first girl, which would give us the same combination. So what we then need to do is divide this by 2 because we're wanting unique pairings. So then that's going to be 3540 divided by 2, which gives us an answer of 1,770. And the reason why we're dividing by 2 is because we want unique pairings. And this will include twice, or 2 duplicates, will include duplicates. So then moving on to question 16, it says how many odd numbers greater than 40,000 can be created using these digits? Now it's really important that we recognize that this question is asking for how many odd numbers are greater than 40,000. So let's first start by representing our 5 digits. Now for it to be greater than 40,000, then this number here needs to be 6, 7 or 8. Now, in order for it to be an odd number, that this number then needs to start with either a 1, a 7, and there we go. Now, for it to be greater than 40,000, then I can't have the number ending in a 7. It's got to be here. So therefore then, how many choices have I got? Well, for the first number, that's going to be 3. Then the second one, there are, and again, 1 has to be this one here. So then there's only possibly 3 numbers to choose from. Then for the third number, there's only 2 numbers to choose from. And for the fourth number, there's only going to be 1. So the final number of combinations is going to be 3 times 3 times 2 times 1 times 1. And that's going to give me an answer of 18. Then moving on to our last question, it says that a pizza parlor sells 10 different pizza toppings. Grace orders a pizza with 3 different pizza toppings. How many different topping pizzas can Grace order? So in terms of a first, second and third choice, well, the first choice, she's got 10 to choose from. In the second, she's got 9 to choose from. And in the third option, she's only got 8 to choose from. So that if I then multiply each of those 3 numbers together, I get an answer of 720. And there we go. So hopefully this makes product rule with counting a lot more easier to understand. Hopefully you recognize it's not just a case of just multiplying numbers together. It is really important that you do read the numbers carefully, understand the question, and I would say use boxes to represent each of the stages or each of the digits when based on these questions. It makes it a whole lot easier to understand. But obviously if you can do it without the boxes, that's going to be fine. You should get the full marks as long as you show you're working out with what numbers you are multiplying together.